Characteristics of waves. In this video, we are going to learn characteristics of waves which were applicable to both transverse and longitudinal waves. They are wavelength, which is denoted by lambda, amplitude denoted by A, frequency f, and the time period denoted by capital T, and the final one is speed of the wave. Let us learn one by one. The first one is wavelength. Let's take a transverse wave. The peaks of a wave are called crests and the valleys are called troughs. Wavelength is the distance between consecutive corresponding points. It is measured in meters. We can measure wavelength between any two points of consecutive waves. There are some millions of points on the waves. We can take any two of them. Here is an example. The first point is at the beginning of first crest and second one is at the beginning of second crest. Same like that, we can measure between any two consecutive corresponding points of a wave. Amplitude. It is the distance from the middle of the wave to the top of the crest or to the bottom of the trough. This means we can measure this over crest or a trough. Another thing we need to remember is the energy of a mechanical wave is directly proportional to its amplitude. Frequency. Frequency is the number of occurrences of a repeating event per unit time. This can also be defined like this: the number of complete wavelengths produced per second. There is an equation for the frequency. Frequency is equals to the number of wavelengths or number of oscillations divided by time. And the units for frequency are hertz. It means cycles per second. Let's take an example problem. Frank is making waves on a rope by moving his arm up and down, which he does 20 times in 10 seconds. Now we need to find out the frequency of the waves that Frank is creating. We know the formula for frequency, that is, frequency is equals to number of wavelengths divided by time. As per the problem, he is creating 20 oscillations in 10 seconds. So the frequency is equals to 20 divided by 10. So the frequency is 2 oscillations per second or 2 hertz. The time period. Period is the interval of time between successive occurrences of a cyclic phenomenon. This can also be defined like this: the time for one complete wavelength to be produced. There is a formula to find the time period of a wave. Time period is equals to time divided by number of wavelengths or number of oscillations. The unit for the time period is second. Let's take an example problem. Kelly is floating on an inner tube in the ocean and notices that she bobs up and down 6 times every minute. Now we need to find out the period of ocean waves on which Kelly is floating. So the period is equals to time divided by number of wavelengths. Here the time is given as 1 minute, that is 60 seconds. So the time period is equals to 60 seconds by 6. So the period is equals to 10 seconds. Now let's try to understand the relation between frequency and period. Frequency and period are reciprocals of each other. Let's try to show them in an equation. F is equals to 1 by t, or t is equals to 1 by f. And finally, we discuss about speed of a wave. Speed of a wave represents how quickly a wave travels from one place to another. Let's try to figure out the formula for speed of a wave. As we know, speed is equals to distance by time. So v is equals to d by t. The characteristics of a wave that is measured in meters is wavelength. The characteristic of a wave that is measured in seconds is period. So we can write the equation as v is equals to lambda by t. That is, speed of a wave is equals to wavelength divided by the time period. Since time period and frequency are reciprocals, we can write the equation as v is equals to f lambda. Let's take few examples. What is the speed of a water wave that has a wavelength of 8 meters and a period of 4 seconds? V is equals to lambda by t. As the wavelength is given as 8 meters and the time period is given as 4 seconds, so V is equals to 8 meters by 4 seconds. So the V is equals to 2 meters per second. Let's take another example. What is the wavelength of a sound wave with a speed of 331 meters per second and a frequency of 500 Hz? V is equals to f lambda. Here the speed of the wave is given as 331 meters per second and frequency is given as 500 Hz. So the lambda is equals to 0.662 meters.